All right, so today's lesson, angle relationships, is kind of a continuation of what we did yesterday with angle measure. We're just going to add on some more angle vocab. We're using basically the same notation that we did yesterday, so let's just keep up with that. Our first definition we're looking at is adjacent angles. Do we know what adjacent means? Yeah, it just means like next to. So two angles are adjacent if essentially they're next to each other. The two requirements for that is that they share a common vertex. So they meet at the same point A right here, and they share a common side. So their common side is that one in the middle. It's AJ. That makes two angles adjacent angles. So I could say something like angle DAJ is adjacent to angle JAT. Remember, we name angles with 3 letters where that middle letter has to be the vertex. Next up is a linear pair. Okay, a linear pair is just a fancy adjacent angle. So it's basically the exact same thing. They have a common vertex. They share a common side. However, the thing that makes it a linear pair, the fancy part, is that the sum of the two measures of the angles is 180. AKA, they form a straight line. So I could say here angle 1 and angle 2 are a linear pair. Now for linear pairs, they have to be next to each other to be considered a linear pair. Otherwise, they would just be called supplementary, which we'll get to in a second. Next up, vertical angles. Vertical angles are angles that are congruent because they are directly across from each other. What I have to make sure that we understand about vertical angles is that they're always going to form an X shape. Okay, vertical angles here, like we have, those vertical angles form an X, which tells me angles 3 and 4 are congruent because they are vertical angles. They share a vertex and they are across from each other in that X shape. And I also know angles 1 and 2 are congruent because, again, they are across from each other, they share that common vertex, and they form that X shape. Now, sometimes it can be tempting when we see something that looks like, oh, how am I going to draw this? Something like this. I see this all the time. Okay, you see this and you're like, oh, vertical angles here and here. That is not considered a vertical angle because it is not an X shape. That to me looks more like a K shape. Those lines, if they're across from each other, do we see how this one is kind of like bendy? Let me see if I can highlight it. A different color here. Okay, this line bends right here. This line, it bends right here, right? So those are not an X shape, that's more of a K shape. We do not get vertical angles if it is not a straight X shape like that. Okay, hopefully we've seen these ones before. Complementary angles are two angles that have the measures that add up to 90 degrees. They can be adjacent like they are in this first example. They share this common side. So angles 1, or sorry, you know what? Let's do the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Okay, so they're next to each other. They add up to 90. They're complementary. Or they could not be next to each other at all. They could be on opposite sides of our piece of paper. As long as their measures add up to 90 degrees, they are considered complementary. So the measure of angle A plus the measure of angle B also equals 90. Same thing goes for supplementary. Supplementary means two angles that have a sum of 180 degrees. Again, they can be next to each other. So remember, we call that a linear pair. Oops. So in this example, the measure of angle 3 plus the measure of angle 4 equals 180. Or Just like complementary, they could be on opposite sides of my paper, nowhere near each other. As long as their measures add up to 180, we consider them supplementary. So here is the measure of angle P plus the measure of angle Q equals 180. Does anybody know any tricks for figuring out complementary versus supplementary? Like which one is 90, which one is 180? Any tricks? Okay, how I always think about it is C comes before S in the alphabet, so 90 comes before 180 in the alphabet. That's kind of dorky. Somebody last class, though, told me that if you take the C in complementary and draw a line through it, you get a 9. And if you take the S in supplementary and draw a line through it, you get an 8. That's how they remembered it, and I think that's pretty cool. I'd never heard that before, so maybe keep that one in your brain. Lock it in. All right, last definition here is perpendicular lines. 2 lines are perpendicular if they intersect to form 4 right angles. We can see one of those right angles is marked. That's going to imply that all the other 4 are also there. So if you got one, you got them all. So we would say that these 2 lines, line AD, remember we use 2 capital letters with a line on top with arrows, is perpendicular to, my sign for perpendicular is an upside down T shape. And then that other line, CB. That's all. Any questions on any of this vocab? Good stuff in here, right? Okay. Let's see how quickly we can do this. You can shout them out if you got them. Can we name a pair of adjacent angles? Any pair of adjacent angles. Doesn't matter. What if I give you one and you give me the other one? What if I say one of them is angle KHL? Can you give me an angle that is adjacent to KHL, Casper? Perfect. 2 adjacent angles, they share this side, KH. A linear pair. Anybody got a linear pair for me? Oh, no. Nolan? Perfect. Vertical angles. Is this a trick question? Do we have vertical angles here? I don't see vertical angles here. Again, look at that shape of these angles. You probably are thinking, oh yeah, GHM and JHK. But this is forming that K shape that I was talking about. This line is straight. This line is bent. We don't want that. We want an X shape. So there are no vertical angles here. Flip it over, next page. Oh my goodness. 2 acute vertical angles. Now this isn't a trick question. We actually do have acute vertical angles here. Do we see them? Where do you see them, Casper? Yep. What's the other one? Well, here's SYT. So VYW does not make the vertical angle. Remember, that's a K shape. My X shape, do we see it? It's right here. If I just extend those out. So that vertical angle is going to be angle WIX. We see the difference between the K and the X. We don't want the K shapes. We want the X shapes. Okay, supplementary angles. Remember, to be supplementary, they just have to add up to 180. The easiest way to find supplementary angles is to look for where are my straight lines. Do we see this straight line here at SYW? Right here, if I cover that up, that forms a straight line. So I'm going to pick 2 angles that make up that entire straight line. I'm going to pick SYT again. And I'm going to pick the one that makes another straight line, TYW. Finish off that linear pair. Ooh, okay, straight angle. That's a definition that we saw yesterday. Do you remember what a straight angle is? Or can you give me one example of a straight angle on here? It's just one angle. Anna. Perfect. Angle SYW. Remember, a straight angle is just an angle that forms a straight line by itself. That angle by itself is 180 degrees. And then a pair of complementary angles, we cannot assume that things are complementary. We can't assume right angles. So we actually have to look and find where a right angle is. So I see that right angle tick mark in there. So the 2 complementary angles are going to be VYW and WYX. So kind of weird. We can always assume that things are straight lines, but we can never assume that things are right angles if it's not shown to us. Okay, couple more examples here. Find X and Y so that KO and HM are perpendicular. Here is KO. Here is HM. If I want to know that they are perpendicular, what should those crosses, like the angles at those cross sections, be? 90 degrees, perfect. So that means I should get a 90-degree angle in here and a 90-degree angle in there. Well, that makes my job for these Y's pretty easy. The Y is 3Y plus 6, and I know that that by itself has to equal equal 90. So 3Y equals 84. Y equals something like 28, maybe? I don't remember what it is. Yep, 28. And then what's my setup for the x's? How am I going to set that equation up to find x? Casper? Perfect. Both parts together have to equal 90. So this is 12x equals 84 again, or x equals 7. Questions on that? Okay, 2 more, then we're done. Find the value of x. What do we see in this diagram? How are we going to set this up? You got it? What you got? Perfect. And why do we know that that equals 180? It's a straight line. We can always assume that things are straight lines. So if it looks like a straight line, it is a straight line. So I got 6x plus 90 equals 180, or 6x equals 90, x equals 15. And then one more. ABC and DEF are complementary angles. I'm given the values for ABC and DEF. I'm trying to find x and the measure of ABC. What is my setup? What's my equation I'm looking for? Yep. Perfect. Complementary means 90 degrees. So I'm setting those equal to 90. And let's solve this. I'm just going to kind of rapid fire through this. 8x equals 40. So x equals 5. Do not forget to plug it back in to find the measure of ABC. So if the measure of angle ABC equals 3x plus 70, I got 70 plus 15, aka 85 degrees. That's all. Any questions on that? Pretty straightforward lesson, right? We got it. I believe in you.